Hello from Tech Tutors. If you're struggling with Java exceptions, you're in the right place. Let's explore exception handling in Java to ensure your programs run seamlessly. In Java, an exception is an event that disrupts the normal flow of the program. It's an object thrown at runtime. Exception handling in Java is all about managing these unexpected events or errors during execution. Java handles exceptions using try-catch blocks. Code that might throw an exception goes in the try block, while the catch block handles the exception. For instance, suppose you're attempting to open a file. If the file doesn't exist, Java will throw a file not found exception. By handling this exception, you can prevent your program from crashing. Exceptions in Java can occur due to invalid user input, device malfunctions, network issues, disk space constraints, coding errors, and attempts to access unavailable files. Let's take a closer look at the hierarchy of Java exception classes. This diagram provides a comprehensive view of how exceptions are organized, starting from the root class throwable and branching out into specific types of exceptions and errors. Java's exception handling revolves around a few critical components. The try-catch block is essential. The try block encloses code that might throw an exception, followed by a catch block that handles the exception. This is crucial for preventing program crashes. For example, if you're reading a file and it doesn't exist, a file not found exception is thrown, which you can handle with try-catch. The finally block comes next, ensuring that necessary code runs regardless of whether an exception is caught. This is useful for tasks like closing a file resource, which must happen whether an exception occurs or not. We also have the throw keyword for explicitly throwing an exception, such as a custom exception for invalid age input in a method. Additionally, the throws keyword is used in method declarations to indicate that a method might throw certain exceptions, like file not found exception, without handling them directly. To print exception details, you can use print stack trace method for a full stack trace, to string method for the exception name and description, and get message method for just the description. When discussing exception handling in Java, it's essential to understand the types involved. Java categorizes exceptions into three primary types: checked exceptions, unchecked exceptions, and errors. Each of these plays a distinct role in how exceptions are managed within your programs. Let's examine the differences between checked exceptions, unchecked exceptions, and errors in Java. Checked exceptions must be handled by the programmer as they are checked at compile time. Common instances include I/O exception and file not found exception, which are typically employed in I/O and file handling scenarios. Unchecked exceptions do not require mandatory handling at compile time and are usually related to logical errors or programming mistakes, like null pointer exception and array index out of bounds exception. Errors represent serious system issues, such as out-of-memory error and Stack Overflow error, indicating problems like system failures or resource exhaustion that are typically beyond recovery. Let's begin with an example of an unchecked exception. In the arithmetic exception example class, we see a demonstration of handling an arithmetic exception in Java. The try block performs an illegal division by 0, triggering an arithmetic exception, which the catch block handles, ensuring the program continues running smoothly. Now, let's move on to checked exceptions with a code example. The file not found exception example class demonstrates how to manage a file not found exception in Java. The try block tries to read the file named non-existent file, causing a file not found exception if the file is absent. The catch block prints an error message, ensuring uninterrupted program execution. Finally, let's discuss errors with a code illustration. In the out-of-memory error example class, we handle an out-of-memory error in Java. The try block attempts to allocate an excessively large array, triggering an out-of-memory error. The catch block captures this error and logs the details, demonstrating how to manage such critical issues before program termination. By effectively managing exceptions, you can ensure your Java applications remain stable and user-friendly. Thanks for watching. For more technical insights, stay tuned and subscribe to Tech Tutors.